Hey guys, this is Professor Janacek. I want to go over an example of the application where we find the length of a curve. So let's find the length of the curve described by y equal to the natural log of x plus square root of x squared minus 1 on the interval from 1 to the square root of 2. Okay, first off, there's some things I notice about this. If I were to evaluate this, I see that 1 is in my interval here. There's a problem there. I notice that for y equal to f of x, f prime of x is undefined at x equal to 1. And if you're not certain, you can find the derivative of y. Find f prime. And it turns out that f has a vertical tangent line. At x equal to 1. Again, finding the derivative, graphing that natural log function, you'll see that there's a problem. So 1 is a problem here. What can we do? Well, let's see if changing this to a function of y will help us. So we start with y is equal to some function of x and let's see, I need to isolate the x. So I need to get rid of that natural log. One way to do that is using its inverse function, which is the e function. So we have e to the y is equal to just x plus the square root of x squared minus 1. All right, so on the part with the x's, I've gotten rid of the natural log. Now I need to get rid of the radical. So let me isolate the radical first. And then we'll clear the radical. So when we square e to the y minus x, we get e to the 2y minus 2x e to the y plus x squared on the left side. If you don't believe that, just take a second and write e to the y minus x, write that out twice, and multiply. Right? You should end up with that bit there. And then on the right-hand side, that's easy enough. We just get x squared minus 1. Okay, I see I've got an x squared on each side, so we can just subtract that out, get rid of it. Makes things a little bit easier. Now I want to isolate the x. The idea is that I'm solving for x. I want x as a function of y. So let's see. I notice that I have some negatives here, so let me go ahead and move things around, possibly in an order that you might do differently, but it should all work out either way. I'm just trying to avoid some of those negatives. And then I can isolate that x. And let's see, we can go ahead and simplify this just a bit. So we have e to the y on the first one and e to the negative y on the second one. So x is e to the y plus e to the negative y over 2. Looks kind of familiar. Anyway, the other thing I need, so I now have the x as a function of y. I also need to make sure that I change my interval. Those are x values. I need those as y values. So when x is 1, y is the natural log of 1 plus the square root of 1 squared minus 1, which ends up being, let's see, that ends up giving us just a 0. When x is the square root of 2, y is the natural log of square root of 2 plus the square root of 2 squared minus 1 ends up giving us the natural log of the square root of 2 plus 1. Okay, now I think we're ready to go. We are using the second formula here, which means, okay, we have our g of y. Our function of y is e to the y plus e to the negative y over 2, right? What we came up with down here. Oops. This stuff right there. Oh, darn it. How about that? There it is. There's our g function. Instead of writing it as x equal, I'll write it as g of y equals. We also need g prime squared. So let's first take the derivative. Oh, goodness. Might be easy. Let's see. Is that going to... Yeah, we'll go with it that way. That's probably the easiest form. Actually, it might be easier if you wanted to factor out the 1/2, you could. But you don't have to. E to the y, if we take the derivative of that, we get e to the y. E to the negative y, again, there's a little substitution that needs to be done in there, but you end up with negative e to the negative y. Of course, this is still all over 2 because that would end up being a constant. So however you want to go about finding that derivative, take your time. If you want to factor out the 1/2, go right ahead. I think that's not a bad idea. But now we need to square this. When we square that, we end up with e to the 2y minus 2 plus e to the negative 2y over 4. Now again, just like we'd seen this before with squaring things, if you're not comfortable with that, then take this, take the e to the y minus e to the negative y, write it out twice, and multiply. Right? You should see that come out to be this right here. But take your time with that. Okay, so there we go. We have g prime squared. So I think we're ready to go ahead and write our integral. Our length will be the integral from, now remember we're looking at y values, so we're going to go from 0 to the natural log of the square root of 2 plus 1. And then our formula says we're going to take the square root of 1 plus g prime squared. That's e to the 2y minus 2 plus e to the negative 2y over 4. Of course, we're integrating with respect to y. Okay, let's see. What can we do with this? It's not looking too pretty right now. But I can combine like terms, right? I have a fraction and a non-fraction. Let's put them together. There are a few ways you can simplify this. I'm just going with this one. So when we combine these two, inside this radical we have, combining the numerators, e to the 2y plus 2 plus e to the negative 2y. So you notice all I really did was combine the 4 and that minus 2 in the numerators. And this is, of course, all over 4. Okay, well, this isn't looking very nice, but I do see something that's going to help us. Inside this radical, I recognize that this looks a lot like this. The only difference between those two things is that what I have now is a positive, what I had before was a negative. And I also know that this one came from all of this stuff squared, which means we can write all of this squared as well, but it's just going to be a positive. Again, that's coming directly from this connection up here. The only difference is that I have negatives there in the numerator. All right, well, that's lovely because now I have in my integrand the square root of something squared. So that gets rid of our radical. Again, this often happens. This is a very common thing to occur with these particular types of problems. All right, so now we need to integrate. Let's see. I will go ahead and factor out that 1/2, make it a little easier to integrate. So we have the integral of e to the y is simply e to the y. The integral of negative e to the negative y, oh wait, that should be a positive there. The integral of e to the negative y is negative e to the negative y. There we go. And we're going to evaluate this from 0 to the natural log of the square root of 2 plus 1. Don't be scared by that. It ends up being not too terribly difficult to work with because we have all those e's in there. But I'm going to go ahead and let you guys have some fun with that. Evaluate this from natural log of square root of 2 plus 1 to 0, and 0 between those two. See what you end up with. It should be a 1, believe it or not. Enjoy!